looking at how we can write a Python program to solve an initial value problem using the fourth order Runge-Kutta method. So I've written out the equations for the fourth order Runge-Kutta method here. It's a single step method where the solution at the next step, yn plus 1, is equal to the solution at the current step, yn, plus a weighted sum of these values k1, k2, k3, k4, and these are given down here. Now these are known as the stage values of the Runge-Kutta method. Now in a previous video I showed you how we can write a program to solve an IVP using the Euler method, and that code is copied and pasted in here. So all I'm going to do is I'm going to adapt that so that we're solving using the RK4 method instead. Okay, so what I'm going to do is I'm going to write a function called RK4. Okay, the inputs to that function are f, which is the name of the ODE function, so that's the ODE we're trying to solve, tn, yn, and step length h. Okay, and in this function I'm going to first calculate what k1 to k4 are. Okay, so this is pretty much as it's written. Okay, so as you can see, you can follow what I'm doing here. It's pretty much as it's written down above. Okay. And finally k4. Okay. Okay, so that's, as you probably see, that's pretty much written as it's written there. And this function will return the yn plus 1, so this is the right hand side of this top equation here. So that's plus h over 6 times k1 plus 2k2 Okay, so there's your RK4 method. So in the solve IVP function which we did earlier, we have this input which is the name of the solver we're using. Now in the previous code we used the Euler method, as you can see there. So now we've got a different method, the RK4 method. It's quite easy just to switch between the different methods. So I'm just going to run that code, and this is for the Euler method, and you can see it's just the solutions we had on the previous video. So all I need to do now is to change to the RK4 method, is change that. Okay, simply change to the RK4 method, and you can see we have the solution. Okay, it's not immediately obvious whether, you know, this is any different from the Euler method solution, but for this particular initial value problem, where is it? Yeah, t times y, the exact solution. Okay, so it's possible. This is a very simple ODE, so it's possible to calculate the exact solution, and that is e to the t squared divided by 2. Okay, so what I'm going to do now is I'm going to print the table of solutions out with the Euler method and the RK4 method, and also compare their plots. Okay, so first thing I'm going to do is I'm going to solve the IVP using both methods. Okay, so using Euler and RK4, so I'm going to just change this to Euler and RK4, so they're different. So this is the y Euler solution, and then I'm going to include the similar thing for the y RK4. And I'm also going to have one for the exact solution. Okay, so to do this, I just simply call the exact solution for the current value of Tn. Okay, I'm just going to see whether that works. Yeah, so we've got 3 columns here, and let's tidy it up. Let's have some column headings. I'm going to sort out the spacing in a minute, so don't worry too much about that right now. Okay, oh, this should have been Euler, shouldn't it? Okay, so just a bit of trial and error really here with the spacings. Just get it neat. You don't have to mess about too much with this. Okay, I'll give it a nice long few more. That'll do. Okay, so you can see here the Euler method solution, the RK4 method solution, and the exact solution. It's quite close between RK4 and the exact. Okay, we're starting to see a little bit different when you get towards the end of the domain, the T domain. But the first few are quite similar. That's because the arcade-more method is much more accurate. As we see, the Euler method was different, and it's also useful to see this as a plot. So we've already got the y Euler. We also need, let's plot a line for the exact. Now, to plot a line for the exact, I need lots of points. So I'm going to create a new array. That solution, I'm going to create a couple of new arrays. So t exact is going to be lots of points between t span 0, which is the first value in t span, and t span 1, which is the last. And also do this, calculate the exact solution using that t exact. Okay, so I'm going to plot t exact against y exact. Use a black line, and I'm going to give it a label, the exact solution. Plot y Euler, I'm going to give that a label with Euler, and plot the RK4 as well. Y RK4. Oh, and kind of plot that in red. Okay, and since I've appended labels, so I've attached labels to these three pots, it's quite easy to add a legend so we can compare which, or see which one is the which line represents which solver. Okay, so just run that. Okay, so from here you can see the plot. There's a black line under here. Okay, the blue line was the Euler method, and we can see that the RK4 method represented by the red line is much more accurate.